Have you ever stopped to consider the incredible wonders right in our cosmic backyard? While humanity often looks forward to distant stars and galaxies, some of the most astonishing discoveries await us much closer to home. Today, we're diving deep into one of the solar system's most mysterious and fascinating worlds, Titan, Saturn's largest moon. A place so extraordinary, it could easily star in its own science fiction blockbuster. Imagine a world where lakes and rivers flow not with water, but with liquid methane. Where rain falls from orange-hued skies onto landscapes sculpted by hydrocarbons. Where the air you'd breathe, if you could survive the extreme cold, is mostly nitrogen, just like on Earth. This isn't fantasy. This is Titan, a moon so unique that it challenges our very understanding of what a moon can be. The story of Titan begins on March 25th, 1655, when Dutch astronomer Cassini-Huygens first spotted this mysterious object orbiting Saturn through his handmade telescope. Huygens, a brilliant mathematician, astronomer, and physicist, meticulously observed this celestial body and calculated its orbital period at 16 days and 4 hours. At the time, he simply called it Saturn's moon, a straightforward but unimaginative name that would stick for nearly 2 centuries. It wasn't until 1847 that John Herschel proposed naming Saturn's moons after the mythological brothers and sisters of Cronus, the Greek equivalent of the Roman god Saturn. This is how our celestial subject earned its majestic name, Titan. For centuries, Titan remained an enigmatic point of light in telescopes. But in 1907, Spanish astronomer Josep Comas I Sola made a groundbreaking observation. He noticed that the central part of Titan's disk appeared brighter than its edges. This phenomenon provided the first evidence that Titan possessed an atmosphere, a remarkable discovery for a moon. The mystery deepened in 1944 when Gerard Kuiper used spectroscopy to confirm that Titan's atmosphere contained methane, a finding that would later prove crucial to understanding this world. What makes Titan truly extraordinary is its atmosphere. The only moon in our solar system with a substantial atmosphere, and in fact, the only atmosphere in the solar system besides Earth that's primarily composed of nitrogen. At approximately 95% nitrogen, with the remainder mostly methane and trace amounts of other hydrocarbons. Titan's atmosphere is thicker than Earth's, with surface pressure about 1.5 times greater than what we experience at sea level on our planet. Here's where things get particularly fascinating. Scientists estimate that all the methane in Titan's atmosphere should have been depleted through photochemical reactions in just 50 million years. Yet Titan has existed for billions of years, and its methane levels remain remarkably stable. This paradox suggests an ongoing process replenishing this vital compound. Could it be volcanic activity beneath the surface? Or perhaps, as some scientists speculate, biological processes producing methane? While we don't have definitive answers yet, this mystery keeps researchers captivated. Titan is an impressive celestial body in its own right. It's 50% larger than Earth's moon and 80% more massive. With a diameter of 5,150 kilometers, it's actually larger than the planet Mercury, making it the second largest moon in our solar system after Jupiter's Ganymede. Despite its size, Titan's surface gravity is only about 1/7 of Earth's, which contributes to its ability to retain such a thick atmosphere. The surface of Titan presents a landscape both alien and strangely familiar. Its dense orange haze, created by complex organic molecules called tholins, completely obscures the surface in visible light. For decades, we could only speculate about what lay beneath this impenetrable veil. But thanks to the Cassini-Huygens mission, we've gained unprecedented insights into this mysterious world. Titan's surface reveals river valleys, sand dunes, mountains, and even what appear to be cryovolcanoes that may spew water-ammonia mixtures instead of molten rock. The most astonishing discovery? Liquid bodies on the surface. Titan is the only place in the solar system besides Earth where stable liquid exists on the surface. But instead of water, Titan's lakes and seas contain liquid methane and ethane. Kraken Mare, the largest of these bodies, spans an area comparable to Earth's Caspian Sea. The weather patterns on Titan are equally fascinating. While the surface experiences only gentle breezes, wind speeds increase dramatically with altitude. At about 80 kilometers above the surface, conditions are remarkably calm. A perfect spot for floating with a book, safe from both the surface winds and the violent storms higher up. Above 120 kilometers, extreme turbulence reigns. This complex atmospheric circulation creates weather patterns that include methane rain, forming rivers that carve channels into the icy landscape. Perhaps most intriguing is the possibility of a subsurface ocean. Scientists believe Titan may harbor a global ocean of liquid water mixed with ammonia beneath its icy crust. This ammonia acts as an antifreeze, lowering the freezing point of water and allowing it to remain liquid despite temperatures far below zero. If this ocean exists, and evidence from Cassini strongly suggests it does, it could contain salts similar to Earth's seawater, creating potentially habitable conditions. This brings us to the most tantalizing question. Could life exist on Titan? While the surface temperatures average around minus 180 degrees Celsius, making Earth-like life impossible, Titan's rich chemistry offers intriguing possibilities. The moon is incredibly rich in hydrocarbons, with complex organic molecules constantly forming through chemical reactions in the upper atmosphere. These molecules rain down onto the surface, creating a prebiotic chemical environment unlike anywhere else in the solar system. Some scientists speculate that if life exists on Titan, it might be based on liquid methane rather than water. Imagine organisms that breathe hydrogen and produce methane as waste, a complete inversion of Earth's biological processes. While purely theoretical at this point, such possibilities expand our understanding of where and how life might emerge in the universe. Looking to the distant future, Titan might become even more hospitable. In about 6 billion years, when our sun expands into a red giant, Earth will likely become uninhabitable. But Titan, receiving more warmth from the expanded sun, could enter a new era where temperatures become suitable not just for simple life, but potentially for more complex organisms. This fascinating possibility transforms Titan from a scientific curiosity into a potential future home for life. Our exploration of Titan began in earnest with NASA's Pioneer 11 mission in 1979, which provided the first distant images of this mysterious moon. But the real breakthrough came with the Cassini-Huygens mission, a joint endeavor between NASA, the European Space Agency, and the Italian Space Agency. Launched in 1997, Cassini entered orbit around Saturn in 2004. And in January 2005, the Huygens probe made history by landing on Titan's surface, the first landing ever in the outer solar system. During its descent, Huygens sent back stunning images of river channels and what appear to be shorelines. On the surface, it measured temperatures around minus 180 degrees Celsius and detected the presence of liquid methane. The data from Cassini and Huygens revolutionized our understanding of Titan, revealing a world of incredible complexity with active geological and meteorological processes. Today, Scientists continue to study Titan using data from Cassini and Earth-based observations. Future missions are already being planned, including NASA's Dragonfly mission, which will send a drone-like rotorcraft to explore Titan's diverse environments in the 2030s. This ambitious mission aims to study Titan's prebiotic chemistry and assess its potential for life, potentially answering some of humanity's most profound questions. Titan challenges our assumptions about moons and planets. It demonstrates that worlds beyond Earth can have complex geology, active weather systems, and potentially even the chemistry necessary for life. It reminds us that the universe is far more diverse and surprising than we might imagine. As we continue to explore our cosmic neighborhood, Titan stands as a testament to the wonders waiting to be discovered right in our solar system. It teaches us that sometimes the most extraordinary discoveries aren't light years away, but orbiting a planet whose rings have captivated humanity for centuries. The next time you look up at Saturn in the night sky, remember that nestled among its magnificent rings is a world where it rains methane, where organic molecules fall like snow, and where the potential for life may be unfolding in ways we've yet to imagine. This is the enduring mystery of Titan, a moon that continues to challenge, inspire, and transform our understanding of what's possible in the cosmos. If this journey into Titan's secrets has sparked your curiosity, stay with us as we explore more of our cosmic neighborhood. Subscribe to join us on the next adventure through the wonders of the universe.